Hello everyone, I am Braj Prajapati. Welcome to my channel Statistics.Education. In this video, we will be learning about scatter diagram. We will also cover its types and its merits and demerits. So let's get started after this intro. So what is scatter diagram method? The scatter diagram method is a graphical method which is used to identify and understand the relationship between two variables. Here, one variable is plotted on x-axis while other one is plotted on y-axis. Here, the intersection points of two variables are marked on the graph paper to represent the relationship of two variables. This method is highly useful when the audience has limited statistical knowledge. Now let's dive deeper by learning about the types of scatter diagram method. There are total 5 types of scatter diagrams and each of them represents different kind of relationship. So let's look at each of them one by one. The first one is perfect positive correlation. In perfect positive correlation, increase in one variable results in proportional and consistent increase in another variable. In this case, points on a scatter diagram forms a straight upward moving line, indicating as one variable increases, the another increases at a fixed rate. Now let's learn this with the help of an example. In this graph, we have the units of production on x-axis and the cost of raw material on y-axis. Here, to produce 5 units, the cost of raw material is 100 rupees. Now, when the production is doubled to 10 units, the cost of raw material also doubles from 100 to 200. Here, the points on the scatter diagram will form a straight upward moving line, indicating that there is a perfect positive correlation. I hope you understood perfect positive correlation. Now let's move on to the partially positive correlation. In partially positive correlation, when one variable increases, the other one tends to increase, but not in a perfectly proportional or linear manner. The data points on the scatter diagram will generally trend upwards, but they won't form a perfect straight line. Now let's understand this with the help of an example. Here on this graph, on the x-axis we have the years of experience and on the y-axis we have the salary in thousand. Here 5 years of experience earns rupees 1 lakh. Now 10 years of experience earns rupees 1 lakh 50,000 and 25 years of experience earns rupees 3 lakh. Now you can notice the points are not increasing at a constant rate. So we cannot draw a straight line covering all the points, but we can draw a line covering maximum points showing a general upward trend. This is the example of partially positive correlation where the variables are increasing but not at a constant rate. I hope you understood partially positive correlation. Now let's move on to perfect negative correlation. In perfect negative correlation, increase in one variable results in proportional and consistent decrease in another variable. In this case, points on the scatter diagram will form a straight downward moving line, indicating that as one variable increases, the other one decreases at a fixed rate. Now let's learn this with the help of an example. On this graph, on the x-axis, we have the number of workers and on the y-axis, we have the production time. To produce one unit, one worker will take 10 hours. Two workers will take 8 hours. Three workers will take 6 hours. Now here we can notice for every increase of one worker, the production time decreases by 2 hours. The points on the scatter diagram forms a straight downward moving line, indicating that there is a perfect negative correlation. I hope you understood perfect negative correlation. Now let's move on to partially negative correlation. In partially negative correlation, when one variable increases, the other variable tends to decrease, but not in a perfectly proportional or linear manner. The data points on the scatter diagram will generally trend downwards, but they won't form a perfect straight line. Now let's learn this with the help of an example. On the graph, on the x-axis, we have the absent days and on the y-axis, we have the marks. Here, when the absent days are 5, the marks obtained is 95. When the absent days increased to 10, the marks obtained decreased to 80. and when the absent days are 25, the marks obtained is reduced to 35. Here we can notice that marks are decreasing as the absent days increases, but the decline is not in a consistent manner. Thus, we cannot form a straight line covering all the points, but we can draw a line covering maximum points to indicate a general downward slope. This is the example of partially negative correlation. I hope you understood partially negative correlation. Now let's move on to the last type of correlation, that is absence of correlation. In the absence of correlation, there is no relationship between two variables. That means change in one variable does not affect the other variable. On the scatter diagram, the points appear randomly or scattered without any pattern or trend, or they will appear in a straight line parallel to x-axis or y-axis. Now let's understand this with the help of these two examples. Here on the first graph, we have salary on the x-axis and height on the y-axis. Here a person's height is 5 foot 5 inches and his salary is 5 lakh per annum. Now if his salary is increased from 5 lakh to 10 lakh, his height will remain 5 foot 5 inches. Even if his salary is increased up to 25 lakh, his height will remain unchanged. Thus, the line will be parallel to x-axis. Now here, if we have plotted salary on the y-axis and height on the x-axis, the graph would look like this. So here, the line will be parallel to y-axis. So it depends where you are plotting the constant variable. On the second graph, we have temperature on the x-axis and hours studied on the y-axis. Here, the temperature and study hours has no relationship. Thus, you can notice the points are randomly scattered on the graph paper, indicating there is absence of correlation. I hope you understood the absence of correlation. Now let's move on to the final section of the video, that is merits and demerits of the scatter diagram. The scatter diagrams are straightforward and easy to draw, making it ideal to represent the data and relationships. One can easily understand the trend by observing the slope of the diagram. The next point is no complex calculation. Unlike any other statistical method, scatter diagram method does not have any formula or complex calculation, making it a simple method. The next point is useful for bivariate data. The graph have two axes, thus making it ideal to represent relationship between two variables. Thus, scatter diagram is specifically designed to represent bivariate data. The next point is useful to explore relationship. Now directly using complex method to explore relationship is time consuming. Thus, scatter diagram provides an easy solution. Based on scatter diagram, one can decide whether to explore relationship using complex methods or not. The last point is indicates direction of relationship. From the slope of the scatter diagram, one can easily identify whether there is a positive relationship, negative relationship, or there is absence of relationship. Now let's move on to the limitations of scatter diagram. The first point is limited to two variables. The scatter diagram method can represent two variables at a time. Thus, it is not ideal to represent relationship involving multiple variables. The next point is provides only visual insight. The scatter diagram method is a graphical method which shows general trend, but they do not provide any precise value of strength of the relationship. The next point is unable to show causality. The scatter diagram can show relationships, but it cannot determine whether one variable is causing changes in another variable or not. The last point is difficult to interpret large data. When there are too many data points on the graph, the scatter diagram will become cluttered and it will be difficult to identify any pattern or trend.